Today, the problem that we're going to be covering is minimum waiting time. And the problem reads, you're given a non-empty array of positive integers representing a time that a specific queries will take to execute. Only one query can be executed at a time, but queries can be executed in any order. And then they define a query's waiting time is defined as the amount of time that it must wait before its execution starts. In other words, if a query is executed second, then the waiting time is the duration of the first query. If a query is executed third, then the waiting time is the sum of the durations of the first two queries. Write a function that returns the minimum amount of total waiting time for all the queries. For example, you're given the queries of 1, 4, and 5, then the total waiting time if the queries were executed in the order 5, 1, 4 would be 11, and that's because the first element has 0 waiting time, the second element has to wait 5, let's call it seconds, 5 seconds, and the last one has to wait 5 plus 1 seconds, which is 6. And then it goes on to explain that. And then it also states you're allowed to mutate the input array, right? Which means you can manipulate the order of how these jobs are ran. These queries are ran. So first, let's sort of take a look at what this question is actually asking. There's, a big long paragraph is what this question is structured as, but I think it's important to sort of go through an example to see what this question is actually asking. And using this example that we get over here, what this question is saying is we're looking for the minimum amount of time to execute these queries, right? So, and how we're calculating that is, okay, so the first job in this set of queries, it doesn't have to wait for anything because there's no predecessor. So the waiting time for the first job is 0, right? Now, the waiting time for the second job, 2, would be 3, right? Because this element, right, this index 2 has to wait for the first job to finish, right? So it would be 3. The waiting time for this, right, would be 5, and that's because this query has to wait for the first job to finish, and the first query to finish, and the second query to finish, right? So that would be 5. For this one, it would be 3 plus 2 plus 1, which is 6. And for this one, it would be 3 plus 2 plus 1 plus 2, which would be 8. Right? And each one of these, right, each waiting time, we're going to add up to find what our total waiting time would be, right? So obviously this is not 17, this is greater than 17, so the order in which you execute these queries matters, right? So we have to sort of determine, okay, so we know how we're going to calculate the waiting time, right? But we have to understand how are we going to order these queries in order to get the minimum waiting time. Now let's take a look at another example, a smaller one, right? Let's say we have the element 100, right? Let's say this is our queries array, right? Just a single element 100, right? Well, the minimum waiting time would be 0, right? Because the first job never has to wait any time, right? It never has to wait. The first job in the queries array never waits. It's the first one to get executed. Now, if we expand upon this, and let's say we have 101, right? We have 2 elements now. We have 100 in the front and 1 as the second element. Well, the first job takes 0 time. The second job takes 100 time, right? Because the second job needs to wait for the first one to finish, right? So now we're at 100, right? Let's size this up even more, right? Let's say we have 100, 2, and 4, right? Now we have 3 elements in the queries array, right? So the first job, as we know, never waits any time, so the duration is 0. The second job is going to weight 100, right? So the first job weights 0, second job weights 100, and then the third job weights 100 plus 2, which is 102. And if you can see, if you can see the pattern here, as the query array grows larger, we really don't want to put the largest elements towards the front, right? That because they're going to be impacting the time of future queries, right? So as this queries array gets larger and larger and larger, we just keep having to add this giant number to the jobs in the future, right? So what we really want to do is we want to do the opposite of this, right? So going back to our example up here, if we first sort, right, so that's going to be our first comment, sort input array, right? So if we first sort the input array, we can see we get 1, well, let's put that there, 1, 2, 2, 3, and 6, right? So this is what we get, right? So now doing this math as an example, so the first one we always know it weights 0 time. The second one weights 1 time, right? The third one will weight 3. So let's, whoops. All right, it will weight 3. The fourth one, this element will weight 2 plus 2 plus 1, 5. And then the last element, whoops, will weight 8, right? And if we sum this up, 3 plus 5 is 8, 8 plus 8 is 16, and then you add the 1, we get our 17. So we for sure know that the order in which these queries should be executed is sorted in ascending order, right? We need to sort the input array in ascending order, right? Array in ascending. I think I'm spelling this wrong. Right. We need to sort that input array in ascending order. And another thing we need to do is we need to initialize variable for our result, right? And then we also need to keep track, well, keep track of previous waiting time. And the reason that we need to keep track of the previous waiting time is if you look in the example above, the first element is always going to be added to future queries, right? So when you go to the second element, let's say 2 for example, you're going to need to include 3. You go to the third one, you're going to need to include 3 plus 2. You go to the fourth one, you're going to need to include 3 plus 2 plus 1. So you're always keeping track of what the previous waiting time is so you can add to it. Maybe it'll make more sense once we start writing the code. And then basically what we're going to do is we're just going to iterate over sorted input array. Then we're going to add we're going to add the, let's call it waiting time, plus the previous job time, right? And then what finally, before we leave the for loop, we're going to update that previous waiting time for the next iteration, right? Update previous waiting time for next iteration, right? And let's see what this is going to look like. So I'm going to delete this example, right? First thing we're going to do is we're going to sort the input array, right? Oops. Then we're going to initialize a variable for our result. So let's say int waiting time. Let's call it waiting time. We're going to set it equal to 0 because the waiting time is 0 to start. And then we're also going to create a variable called previous waiting time, initialize previous waiting time. So it prev waiting time. It's going to start off at 0. And one of the reasons it's starting off as 0 is because we know once we start iterating through our sorted queries array, the first element doesn't have to wait for anything. There's no duration or waiting time for the first element. So that's why we initialize this to 0, right? And then we're just going to do this. So we're going to say for each int, I'm going to call it a job in queries, right? We're going to say the waiting time is equal to the waiting time plus the previous waiting time. Prev waiting time. Yep. Copy that name. Okay. Right. And again, to reiterate, before we exit this for loop in this iteration, we need to update the previous waiting time so that when the for loop goes to the next job, it can properly add this to our total sum, our minimum waiting time, our result, pretty much. Right? So then we say prev waiting time is equal to the previous waiting time plus this new job, right? X. And looking at the initial for loop step, we can see, so waiting time is going to be 0, previous waiting time is going to be 0, right? So we're pretty much going to do 0 plus 0 is what our waiting time is going to be in the first iteration. And that makes sense, right? Because the first element in the array doesn't have to wait for a job, right? And then lastly, what we're going to do is we're just going to return our waiting time, right? And I think this should work. Let's run that code. Nice, 15 of 15 test cases passed, submit, and we're good to go here. Yeah, so I think the big thing with this question is just realizing that you need to track the previous waiting time for the next iteration, right? So the previous waiting time starts off at 0. Then you update your result, which in this case is the variable waiting time, and then you increment the previous waiting time with the new job for the next iteration, right? All right, that's it. Thanks for watching. Like, share, and subscribe.